Okay, so let's talk about gears. Gears, wonderful toothy little things. There's one on the screen right now. Here, it's got 8 teeth. You can make it turn. Okay, so it's turning at 8 RPMs, which happens to be the speed that the motors that I'm going to ship you will be turning. So keep that in mind. We add another gear. Let's add another 8-tooth gear. And remember, the top one is the one with the motor attached to it. Anyone want to predict which direction the second gear is going to move and how fast? Okay, I can't hear you, so check it out. It moves the opposite direction, and it looks like it's moving the same speed. Probably is moving the same speed because the gears have the same number of teeth. The way to think about, because if you vary the number of teeth, the speed changes. The way to think about that, or one way to think about that, is if you unrolled these gears into strips, they'd both be the same length. But if the second gear were, say, 16 teeth, right, now is the second one going to go faster or slower if the first one is being turned by a motor? So if you unrolled these gears into strips, the second one, the bottom one, would be twice as long, yes? So for the first one to go, when the first one goes around once, it's only going to cover half of the second gear. So this sort of tells us that the second gear is going to go half as fast. And behold, they look like they're going the same speed. They are going the same speed at their edges because the teeth are meshing. But if you follow the white dots, they're about to meet here. Okay, they're meeting now. The top white dot is doing a whole revolution, but the top red dot is white dot is done, and the second one is only halfway around. So they're mathematically inversely proportional. So the speed ratio here is 1 to 2. So if you need to cut the speed in half, the speed is measured at the axle, which is a little x in the center of the gear. Yeah, so if you need to cut the speed in half, you double the number of teeth. And vice versa, if you need to cut the speed, you need to double the speed. Let's double the speed. Let's take this one back down to 8. And let's edit this gear. I think I can do that. Shift Enter, set up in the Okay, let's bump up this number of teeth. Now the first one is still going 8 RPMs, but the second one's going 16 RPMs at the shaft. RPM stands for revolution per minute, by the way. Okay, so that's cool. There's one other thing that's happening here. You're varying speed by the proportion, the ratio of the number of teeth between the gears. But you're also varying what's called torque, which is just force in a circle, rotational force. So right now, the second one is going faster, but it has half the amount of torque. It's easier to understand the other way around. Let's put this back down to 8 and this one up to 16. Okay, so the second one is going half as fast, but it's got twice the grunt. It's got twice the torque. And this comes into play when you're riding a bicycle. You shift into a lower gear to go up a hill and you go more slowly, but you have the power to get up the hill. Whereas if you're in a high gear, the one for going fast, it takes too much force on your legs and the pedals to go anywhere, and you stop and fall over. Let's have a look at the bicycle concept. So with the chain, it's just like the gears, with one difference, and that is that they're moving the same direction. So this bicycle, the pedals are on the chain wheel on the right, and I guess the back wheel is on the left. It looks like the back wheel is going about twice as fast as the person is pedaling. So this would be for going downhill or maybe on the flat if you're kind of strong. So what bicycles do, bicycles that have more than one speed, is they have a thing on the back called a derailleur. which, so this right here is a end-on look at the bicycle gears in the back. There are a bunch of different ones. In this case, there are 5. And the chain is slipped from gear to gear by the derailleur, by this little thing down here, when you pull the lever or twist the grip. So basically you're changing the size of the second gear. So if we're going uphill, you'd want to have it on the biggest gear, like it is here in this diagram, because this is the speed of the chain wheel for pedaling and the back wheel are about the same. Well, it's a little bit faster in the back. But if you were to switch gears, so now this thing is, the derailleur has switched down to the next gear, and so is this. And you're slowly getting to where the back wheel is going faster, but with less torque. And the bicycle is flattening out in the diagram. This thing's really fast for some reason. See what's happening? Yeah. All right, so that's my little bit on gear ratios. There are just 2 things to remember. Speed is a function of the ratio of the teeth, or the diameters, which is the same thing because the teeth have to be the same size. And torque is a function of the same thing. When speed goes up, torque goes down. There's no free lunch. All right, that's it.